Good morning, students. Today we will discuss about basic concepts of chemistry. So this is first lesson from NCERT textbook, volume 1. So first one is nature of matter. So what is matter? Anything that occupies space and has mass is called as matter. For example, if you take water in a bowl, so this water will occupy some space and also having some mass. So you can consider this water as matter. Suppose we have taken any one gas in a balloon. So gas in a balloon. So this gas also occupies some space and also having some mass. So we can consider this gases also as matter. So like that, anything that occupies space and has mass is called as matter. So examples you can say pen, pencil, everything. Okay. Next, classification of matter. So classification of matter, generally there are two ways of classification. One is physical classification, another one is chemical classification. According to physical classification, so this is physical classification, matter can be divided into three states mainly: solid state, liquid state, and gaseous state. And this is chemical classification. So according to chemical classification, matter can be divided into pure substances, next mixtures. Again mixtures divided into elements and compounds. Mixtures divided into homogeneous mixtures and heterogeneous mixtures. So we will see first physical classification, properties of solids, liquids and gases, and interconversions between these three states. After that we will go for chemical classification. So now properties of solids, gases and liquids we will see. Solids have definite shape, size and volume. Solids have definite shape and volume. Liquids has definite volume, but there is no definite shape. Shape of liquid nothing but shape of container. Gases do not have definite shape and do not have definite volume also. They can be expanded or even compressed. So now I will explain about these properties by taking few diagrams. You will get clarity. So now what I said, solids have definite shape, volume. Suppose if I take a 10 liters container, this is 10 liters container, 3 10 liters containers I am taking. So there are 3 10 liters container, 10 liters, this is also 10 liters and this is also 10 liters. Now in this I have taken 1 kg of sugar. Sugar is solid. So here I have taken 1 liter of water. So in this container I have taken gas, any gas. I have taken gas in this container. Suppose this is sealed container. Now you see, this sugar crystals has specific shape and it occupies some space in the container, some specific volume in the container. Similarly, this is solids. These liquids, in case of liquids, this 1 liter liquid occupies 1 liter volume, and water molecules also has shape that we will discuss in chemical bonding chapter. Next, if you see this gas, so if you pour any gas in the container, between gas molecules there are very less attraction forces. So they can move randomly and they can occupy total available space for them. So whatever the quantity of gas, it occupies total volume available for them. So 10 liters it occupies. There is no specific volume for gas. Suppose same quantity of gas, if I take in 20 liters container, it occupies total 20 liters. If I take in 40 liters container, it occupies 40 liters container. That's why gases not having specific volume and liquids having specific volume, solids also having specific volume. And regarding shape, so gas molecules, particular gas not having any particular shape also. So means bulk quantity we are talking, shape of the gas means in bulk quantity. So in case of liquids, so we are saying there is no definite shape for liquids. If you take in different containers, the liquid, suppose if I take same liquid in this type of container, if I take, so this is one container, same liquid if I take this in this container, then the liquid shape becomes like this. So that's why the liquid shape means we can say container shape. Okay, this is about properties of solids, liquids and gases. So same thing here they given. Next, interconversions between solids, liquids and gases. We can interconvert one form of matter to another form of matter by changing temperature and pressure conditions. So for example, ice is there. At 0 degree Celsius, there is a equilibrium between ice and water. If you increase temperature more than 0 degree Celsius, what will happen? So ice starts converted into water, that is solid starts converted into liquid. The process is called as melting process. So solid converted into liquid means that is melting process, and liquid converted into solid means that is called as freezing process. So here one important thing, so that is melting point, freezing point. Melting point and freezing point. So what I am saying, suppose if you take ice and ice converted into water. So this is possible at 0 degree Celsius. Suppose if you take 0 degree Celsius, at 0 degree Celsius, this solid ice and liquid water will be in equilibrium. Both states can exist at 0 degree Celsius. If you raise the temperature more than 0 degree Celsius, what will happen? Ice starts converted into water. If you decrease temperature less than 0 degree Celsius, then water starts converted into ice. So this 0 degree Celsius is a transition point between ice and water, means solid and liquid state. So we can say melting point of ice. Melting point of ice. How much we can write? 0 degree Celsius. Same thing we can write liquid converted into solid means water converted into solid means freezing process. So freezing point of water, freezing point of water equal to 0 degree Celsius. Don't confuse here. Freezing point and a melting point, these are same for a given substance. Similarly, remaining conversions. So liquid converted into gas, that is condensation. Sorry, liquid converted into gas, boiling, and gas converted into liquid, condensation. And solid converted into gas, that is sublimation process, and gas converted into solid, that is solidification process.